So let's see how deep learning can be used to automate damage assessment after a natural disaster. We are looking at Malibu in Southern California. That was an area that was affected by the devastating Woolsey fires last fall. And with over 11,000 buildings in the fire perimeter, USAA, which is the insurance provider, needed a fast and scalable way to settle claims. And they turned to deep learning for that. And the first thing that deep learning needs is several examples to look at and learn from. So they labeled a small fraction of these homes as damaged or not. So let's zoom in and have a closer look. And you can see homes highlighted in red are the ones that are devastated by the fire. And there are several examples of homes shown in green which are still standing. And we can use the export training data tool in ArcGIS Pro to export image chips that will be used to train our model that I'm actually using in this ArcGIS notebook, where I've imported ArcGIS API for Python that now lets you train these deep learning models. Here are those image chips that we just exported, and they contain several examples of which homes are damaged and which are not. And using these, we'll be training a feature classifier model. That's a type of model that's essentially going to go to each geographical feature, look at the imagery around it, and classify or categorize it as belonging to a damaged or undamaged home in this case. The Python API includes tools like FastAI's Learning Rate Finder that help you tune the parameters needed to train your model. Here's the code that's training the model, and in a few training epochs, we have a model that's over 99% accurate at finding these damaged homes. And here are the results. The model has done a great job and correctly identified this home as damaged, and it's found several undamaged homes as well. Once you have a model that's trained, you can save it out as a deep learning package that can be used for inferencing directly in ArcGIS Pro or in Image Server. Here, I'm finding these damaged homes in the notebook in this layer that can be brought inside of ArcGIS Pro. And here are the 11,000 buildings correctly identified using the deep learning model. That is the power of deep learning. Zooming in, we can see all these homes have been correctly identified as being damaged, while the ones in green are still standing. With over 99% accuracy, we have a model that's approaching the performance and accuracy of a trained assessor. That shows the power of deep learning. Thank you, and over to you, Ewan.
Thank you very much, Rohit. So what does that really mean in terms of what you can use in your own work? I think a customer success story is useful here. So we have a customer who's responsible for the national mapping for a country, and they used the tools that Rohit showed you to try and classify buildings, roads, and parking lots. And this is in a country that's rapidly growing, so they have to do this every single year. And what they found was in a matter of hours, they were able to do the work that had been taking 5 workers 1 whole year to perform. So they have much more up-to-date data feeding into their GIS system. So that kind of gives you an insight into the power that's available using these tools. So I'd like to pass it straight back to Rohit, and he's got some examples with other data types that you can use deep learning with. Rohit.
Sure, thank you, Ewan. Geospatial information doesn't always live in a map. Here we have a folder with around 3,000 reports. These are actually police reports obtained from the city of Madison, Wisconsin. Let's have a look at one of them. It says that a 13-year-old boy pointed a handgun at a couple of older teens and was arrested in the 1500 block of Troy. That's an address, but it's in an unconventional format, more natural language format. Now, it goes on to say that this person was, the weapon actually, which looked real, turned out to be a pellet gun. So it's not as scary as it sounded. But as you can see, there's a wealth of information in reports like these. How can we use the rapid progress in natural language processing and bring it into GIS, get this information on a map? For that, again, we are using ArcGIS notebooks, and we've labeled 5% of these reports. 150 out of those 3,000, we've marked the crime, when it occurred and where, all the addresses in the report, who reported it and when. And this serves as a training data to train our natural language processing model. Using the Python API, it's as easy to train an NLP model, a natural language processing model, as it is to train computer vision models. We're just bringing in that data and training an entity recognizer model, fitting it to that data, and once we've trained that model, we can then apply it to an entire folder of such reports, the folder that we're just looking at, and it's created this data frame that has in the first column the text of that report, and in the subsequent column we've extracted the crime, the addresses in each report, the weapon used, who reported it and when, and also a natural language form of when the crime actually occurred relative to when it was reported. So we've got all this information, and to get it into our GIS, we can use the Python API. Here's a method that's essentially geocoding all of those addresses, and it creates a layer that we can then visualize on a map. So let's look at the results. We can see all those crime reports mapped out. And this is all the information. It certainly wasn't evident earlier. Let's zoom in, and looking at one of these reports, it says that an argument between co-workers led to a stabbing early this morning. And so the crime was stabbing. It goes on to describe a weapon, which was a knife, which caused a non-life-threatening injury. And there's more information. So let's see what kind of information our model was able to extract from this. We can see that it has found that the crime occurred early this morning relative to when it was reported. It found the weapon used was a knife, and the crime was stabbing. Let's take a look at this other report, which talks about several people hearing a couple of gunshots early Saturday morning. That's when it occurred. There's an address because of which it was geocoded. It talks about witnesses saw a handgun. That's a weapon that was used. And in this case, there were no reports of injury or property damage. So once again, let's scroll down and have a look at what the model found. It has been able to find when the crime occurred relative to when it was reported. Here's the officer who reported it. The weapon used was a handgun, and the crime has correctly been identified. So now that this information is on the map, we can start really answering questions like, where in this city does crime tend to occur the most? And that's where the analysis tools in ArcGIS Online come in handy. So here we are using the Find Hotspots tool to find the statistically significant clusters of crime. Now, in the interest of time, I've already run this tool, and here are the results. This is the area in the city where crime tends to occur the most. And that certainly wasn't evident when all we were looking at was a bunch of these reports. So that was an example of using text. Now let's look at video, and let's talk about something important: catfish. They are fun to fish and quite tasty, I'm told. I wouldn't know because I'm a vegetarian. But did you know that catfish are actually an invasive species that can cause environmental damage? Here are a few other species that do that. Now, catfish are native to the Mississippi River drainage system, shown in red here, but they've been introduced to all of these, all across the US, where these dotted, the black dots show, because they want to encourage sports fishing. And that's the problem, because catfish are apex predators that eat everything else, they outcompete everything, and they have a lot of offspring. And for that reason, they're causing a decline in commercially viable species like the American shad and the blue crab. And that's why researchers need to find where they exist and perform age and growth statistics. So researchers at Virginia Commonwealth University use drones to create this video where the catfish have actually been encouraged to come to the surface by giving them a gentle electric shock. That's known as electrofishing. It's not supposed to harm them. I don't really believe that story. But nevertheless, now we have this video and we can start performing these studies. Now, ArcGIS already has support for full motion video. So we can go to ArcGIS Pro and get this video inside of Pro. And we can use tools like extracting frames from this video, which essentially georeferences them. And that's when the researchers can do their study, identifying, measuring, and counting these catfish. But that's terribly inefficient. There has to be a better way. Well, thankfully, the same tools you just saw also work with oriented imagery and full motion video. So now we can take this data and train a catfish detector. So this time, we are training a model known as a single shot detector, so-called because of its ability to find all fish, in this case, in one glance. The same training methodology, and here are some results. We saw that it found on the predictions on the right, it even found a couple of fish that were not labeled correctly. So the model has now really learned to find where these catfish are. And what's great is that in the most recent version of the Python API released just over a week ago, you can now take these models and find these objects in an entire video. It even creates a CSV file which contains information on where these objects are in each frame and how big they are. So let's look at the results. We can see as the fish go in and out of water, they are being detected and being tracked. And there's a bounding box around them because of which we can now perform the age and growth estimates. But since we have support for full motion video in Pro, we can now use this new tool in ArcGIS Pro to find these fish floating not just in the video, but also on a map. And that's where you can really start answering questions from the fishermen who want to know how many fish there are, to the commercial watermen who want to know what's happening to their blue shad, to conservationists who are concerned about species loss. That's how you can take data science and deep learning from the notebook into the field and solve real-world problems. Thank you.